So nice. So I'm the speaker to keep you engaged for the next 40 minutes or less. Since I already have my 60% of my environment set up, so I'll start with just a few slides to lay the foundation. Then we get to jump straight to the demo. So this is the part where Google requests you to confirm that you are not a robot. So I'll do a bit about myself. My name is Macharia. I'm a Google developer expert for Google Cloud. I do wear several caps in the community advocacy in the Kenyan tech ecosystem. So for today, I'm a Google. So if at all you have any question with regard to this session or want more practical guidance with regard to Google Cloud, always feel free to connect with me on X and also on LinkedIn. So before we move on, let's take a brief moment of silence for the passing of the Gemini CLI. Nice, nice. Thank you for that respect. So I love how no one has unmuted for a whole minute. That's the most respectful silence that I've gotten to see in a DevOps session. So I could only hear the pods running. Interesting. So let me speak for myself. Gemini CLI served me well, but Google does what it does best by pulling the plug. But don't worry, the Antigravity CLI is here, faster, stronger, and also with native GKE support. So anytime you hear me saying GKE, it means the Google Kubernetes Engine. So the Gemini CLI is gone, but like any other good tech tool, it lives on in our Codelabs and also in our hearts. So what is this Gemini CLI that you keep hearing me talk about? So the Gemini CLI was the old command line tool that used to interact with Google's AI assistant for cloud operations and also for code generation. So now we have this new tool that is the Antigravity CLI. So this is the new upgraded platform engineering tool built to replace the Gemini CLI with faster workflows and also the native GKE support. So Google did announce the sunset of the Gemini CLI at the Google I/O Extended conference that was around May 19th of 2026, this year actually, with the official deprecation and service cutoff taking effect on June 18th, 2026. So the reason certain Codelabs and instances still work is due to this thing of the enterprise exemption, one of the reasons. So Google did not completely shut down the backend for all tiers. Organizations and developers who hold the paid Gemini Code Assist standard and also the enterprise licenses, as well as those using the paid JIP licenses and also the API keys. By JIP, I mean the Gemini Enterprise Agent Platform API keys, formerly referred to as the Vertex AI. They still have that uninterrupted access to the Gemini CLI. Then second is also the Cloud Shell pre-configurations. So Codelabs hosted within Google Cloud, within Google Cloud Shell environments, and also tied to temporary enterprise sandbox credentials, they often route requests. So through these standard and also enterprise billing channels, they can be able to automatically keep the CLI functional for learning purposes. So for free users and also the pro and also the ultra subscribers, the June 18th cutoff was just a hard restriction before a migration over to the new agent first Antigravity CLI. So you might be asking yourself, why is Antigravity CLI important to me? So one of the reasons is the native GKE integration. So the Antigravity CLI connects directly to Google Kubernetes Engine, so letting you to deploy, scale, and also manage containerized workflows without external plugins or workarounds. Then the second reason is the agentic automation. So the Antigravity CLI adds these functions of adding the agent first deployment platform, allowing agent to autonomously handle the multi-cloud resource discovery and also the execution. So now there's a big shift in terms of the capabilities that the Antigravity CLI brings on board. So we are looking now at a major upgrade in terms of how we manage and orchestrate our clusters. So we are moving away from the legacy GKE control plane setup. And what's new? So Google has introduced the fully managed GKE MCP server. MCP is the model context protocol. I know most of you have interacted with it, which is now generally available, by the way. And why does this matter for us as DevOps engineers? So this new managed service provides a containerized secure gateway that lets AI agents directly and also autonomously communicate with, monitor, and also manage our Kubernetes infrastructure securely. So what are some of the core capabilities of the GKE MCP server for developers? So number one is the autonomous AI management. So Antigravity CLI gives AI agents the ability to directly inspect, monitor, and also manage GKE clusters and Kubernetes infrastructure without needing manual platform engineering intervention. Then second, it's the secure AI agent access layer. So the Antigravity CLI connects AI agents to clusters using secure stateless HTTP endpoints that integrate natively with Google Cloud A&M, that is the Identity and Access Management, removing the need to manage and also to expose the long-lived credentials. So I like using visual diagrams since psychology shows that human beings remember images better than just blocks of code that might mark the presentation. So this one just gives a simple overview of our workflow as developers as we write code for that favorite Python application or Java or JavaScript application. Then you get to commit code, then you trigger CI/CD to build that Docker image. Then you later push it to Docker Hub or private registry. On the Google Cloud side, we use Google Container Registry. Azure, they also have the Azure Container Registry, etc. Then you finally pull it onto a server for deployment. Then Docker does its thing. It makes sure that the app runs the same everywhere. Then this diagram now shows the Docker journey. So we start with code in GitHub. Then we get to define the environment in a Docker file. Then build an image and run it as a container. And with the Docker push, the image goes to Docker Hub or private registries like the Google Container Registry or also the AWS ECR, that is the Elastic Container Registry. And wherever you run it, the result is always the same. So this is just a high-level overview of some of the components that are in the Kubernetes architecture. So starting from on my left, there's a control plane. And on my right, there's a worker nodes. In some documentation, you might see it being dubbed as the data plane section. So on the control plane, we have several components. So starting with the API server, that is the Kube API server. So this is the front door of your Kubernetes. It receives a request like creating a pod and updates the cluster state. Then there's also the HCD. So this is just a distributed key value store that saves all cluster data and configuration. There's also the scheduler. So this one watches for new pods and decides which worker node should run them. Then there's also the controller manager. So this one ensures that the desired state of the cluster is maintained. So machine, a virtual. I just wanted to confirm I'm still in the session. Nice. So worker node is basically like a virtual machine where our application is running. So it has several components. So starting with the kubelet. So the kubelet is the agent running on each node. So the work of it is to talk to the API server and makes sure that pods are running as instructed. So then there's also the container runtime. So this is now the engine. So for example, like a Docker or container did that actually runs the containers inside pods. Then there's also the pods. So the pod is the smallest deployable unit in Kubernetes, and each pod wraps one or more containers. So the entire flow, this is how it works. So a user requests a pod, then the API server records it in the HCD. Then the scheduler is going to pick the best node depending on the resources defined in the manifest file. Then the API server tells the kubelet on that node. Then the kubelet uses the container runtime to start the pod. So in short, the control plane is the brain of the cluster. And the worker nodes, these are basically like the muscles that run the workloads. So I dropped this screenshot or snapshot of this Kubernetes simplified file to show some of the different files that exist in the Kubernetes environment. So Kubernetes uses many YAML files called the manifest to define how apps run. So for example, like the deployment, service, config map, secret, PVC, that is persistent volume claims, and also the ingress. So together they describe the app, its environment. So this diagram basically shows how code flows from GitHub through CI/CD, Docker images, and finally through to Kubernetes, where these manifests make everything work consistently. So this is just an example of a Kubernetes manifest file borrowed from Ticob's LinkedIn channel. And with it shows how to configure an application and to define things like the pod name, labels. So as you can see, the name of our pod as defined in the metadata section of this snapshot is TechOps pod. Then you can also add labels to be able to allow you to select this particular pod. So now you can imagine that if I'm an intern and I'm asked to basically try to debug an issue in 1,000-line manifest application. For example, I'm going to do a demo on a company called Cyber. Cyber is an internal application that we usually work on as DevRel engineers. We can be able to debug different manifest file. So it's like, I would give an example of the Bank of Uganda. So a company like the Bank of Uganda, it has obviously a lot of manifest file to probably host the different services of the application. Let's say, for example, the backend, a front end. So it will definitely going to be something to torture my brain if I'm going to have to debug this manually. So where do I start? So with Antigravity CLI, given the access of Antigravity CLI, you're going to give it access to your project directory. Then you can be able to easily scan and validate the manifest, highlight misconfigurations, and narrow down the problem. So instead of manually combing through every line, Antigravity CLI helps you focus on the basics first. So you simply need to define it in your skills.md, something we refer to as harness engineering. You get to define the environment around your AI environment. So then you can be able to easily debug to avoid the painful process of doing it manually. So this Codelab is titled Cloud Engineering's AI Toolkit, Platform Engineering on GKE. So I'm going to give you a minute to probably scan the QR code, or I can also drop a link to the demo. So this was Google's original AI-powered interface for debugging Kubernetes manifest and also workflows. So even though it uses Gemini CLI, which has been depreciated, and it also no longer receives updates, it can still be accessed for learning and also experimentation. So don't worry. I'm also going to show you how to basically install the Antigravity CLI, although it comes pre-installed and also pre-built on the Cloud Shell environment. So the key idea here is to show you how to get to use AI tools with context, like the Gemini CLI back then and the now Antigravity CLI, which can help you as engineers to debug complex deployments faster by connecting directly to project files and cluster states. So take a minute to scan the QR code. I see we are still on time. And I'm also going to drop
consistency.
I'll guide you through this. Stephen, what screen can you see right now?
Yeah, we can see a screen split between your Google Cloud Shell and the browser, the MD file, like an MD file or the docs. Yeah.
Nice. So let me start by authorizing in my Cloud Shell again. It should be done in the next 10 minutes, then give you back the next 10 minutes to basically ask questions. So this is essentially the Codelab. It has several steps, basically 9 steps. So the first part is the introduction, taking you through some of the concepts, like understanding what platform engineering is, then the Gemini CLI, the MCP. Yes. So then after that, you get to the project setup. So this is where you get to learn what are some of the tools that you need to configure. In this case, I just need to have access to the Google Cloud Console. So if I click here on the Google Cloud Console, it's going to open up to the console.cloud.google.com. Then I simply need to select a project that I need to work on. So in this case, I've already selected the GKE tutorials. Maybe I can try expanding this. So this is it. I've already selected this current project. So you can also consider selecting another project by creating a new project here. So I'm going to proceed with this one. Then after that, I have some few commands that I need to key in. So I start by cloning the current repository, this one. Then I cd to the devrel demos. Then I need to do a pass checkout. So this one now allows me to just work with a particular folder of this large repo. Then after that, I need to navigate to the lab directory where I'm going to activate the Antigravity CLI. So I do exactly that. So don't worry about this. This is just an overview. Then we are going to shift to my working environment. Then I need to export the current project that I'm working on. That is the GKE tutorials. Then I also need to configure the region that I want to deploy my resources in. So for this case, I want to deploy my resources in US Central 1. Then I run this script. This is going to enable the different APIs for GKE. So in this case, I'm using GKE Autopilot. So using the /setup.sh, I'm going to enable these different APIs. Then I'm going to introduce some broken files. So maybe I can show you that. So as you can see on my right, there are different Kubernetes configuration files. So starting with this on the front end side of the Symbol Bank. So I told you this is a retail banking system that I'm working on. It's using Kubernetes. So as you can see, this is a service type. So this one is going to allow the users to be able to have access to the front end part of our application on port 80 HTTP. Then there is more to be defined here. Then as you can see, there is also the image. So this is the image that has been built using Docker. It's identified here in the spec configuration area. Then there's a lot that can be seen from this repo. So I'm assuming I'm this intern. I have no idea of where exactly do I look if anything is broken. So this script is going to introduce some broken manifest file in my working environment here. So then after that, I'm going to navigate to where I'm going to give the Antigravity CLI access to my current project directory. So I move to the next section. So this was the old school way of troubleshooting without using AI. So I'm going to repeat this part. So let's do this together. So I need to navigate to that. Path. Then after that, I need to do a kubectl apply -f. So now with this command, what I'm telling Kubernetes is to apply these changes in the Kubernetes manifest folder. So as you can see, I've not done any minor changes. So it's going to give me that feedback of there's nothing unchanged, or there's nothing that has changed in the files that you want me to make changes in. Then after that, I can be able to get more information about my pods to see if they are currently running. So I use the kubectl get pods. So as you can see, I have several of them that are running. Then one of them is giving me the error of create container config error. So this one means that it's experiencing some configuration issues. And there's also another one that is giving me the image pullback off. That one mostly happens if it cannot be able to pull the image that it has been defined in the manifest file. So then after that, so there's more information on how to debug this manually, which is a very hectic process for me as an intern at this bank that I've just joined. So what's the solution to this? So we are still saying that AI is the anthem of the century. So at first, most of us as DevOps engineers, we used to use the web interface, that is the Gemini web UI. So the common way of doing it is by giving the Gemini web interface a simple prompt like this one. So for example, my Kubernetes deployment for user service is filling with image pullback of like the error that you can see on my right part of my screen here. So here is the image name. So what's wrong with this? So I did just exactly that. So as you can see, AI is always going to give you a response. So it's just going to point out where exactly are you going wrong. So as you can see, this one is telling me that there might be an incorrect image name. So which is, it's obviously correct, but the issue is that it doesn't have visibility into my working environment or my project here where I'm working on. So what's the solution to this? So this is in step 5, where we add the capabilities of AI. So we need to just basically incorporate the Gemini CLI into my current environment. So I just need to go to the Cyberbank project repo. Then after that, to invoke the Gemini CLI, I need to write Gemini. So if I was using the Antigravity CLI, so so as you can see, I've already started the Gemini CLI. So maybe something else that I can also show you is that during the installation of the Antigravity CLI, the same approach is used, the same way that you have used in the Gemini CLI installation. So there's this script that you need to run if at all you're using macOS or Linux. There's also a script for you to run Antigravity CLI in your Windows machine. So if at all you want to start Antigravity CLI, you simply use AGI, Antigravity, the short form for Antigravity, this one. So for this, we want to use Gemini CLI. So you go back to our Codelab. Then the first prompt that we want to give our Gemini CLI on this interface is that we want to understand as interns, what is this application and what does it do? So I'm simply going to drop my prompt right there. So it's going to think, exploring, going through the files, initially going through the readme file. So let me expand this one. So as you can see, the Gemini CLI has access to my project, and it's telling me that I have a sample microservices based web application that simulates a bank's payment processing network. What more, it's also telling me the architecture of the application, the tech stack, and also the different services. There's a front-end part, the ledger, writer, balancer, reader, etc. So we can also try to now find ways to debug the issue. So I already have the prompt with me. I just need to drop it right here. So it's going to take some time, go through the README file again. I hope that the demo gods are going to work with me today. It's interesting how AI takes its sweet time when we need it the most. So it's thinking. Still taking time. So if AI is taking this much time, what if I was doing this manually? So probably it would take a month or so to debug where the issue is. So it's still trying to find where the issue is. It has found around 12 items. Reading through the different files. Finally, it has found something. So this is where we say that AI cannot replace you, because you see it's still coming back to ask me for permission to be able to go forward with this change. So it's going to request me to give it permission to make this change. It has found the selector that has an issue. In this case, it's the contacts backend. It wants to replace it with the simple label of app contacts. I just need to give it permission. This is just an example of a human in the loop. Then it's going to move forward, making the changes. 6 minutes. Still taking its sweet time to think. Searching through the different manifest file. So in this case, it's working with the contact.yaml file. Still taking its sweet time. Nice. So it's coming back with another issue that it has found. We need to make sure that the correct configurations for the port are where put in. So for example, for this, we had 2 semicolons for the port that we want our service to be accessed using. So I need to give it permission. So I do exactly that. Still asking for more permission. Then it's going to continuously try to edit more manifest file, giving us feedback on what it has fixed. So then on the next step, we need to fix the label mismatch. So I need to copy that prompt. Then allow it to fix it for me. And there it is, the fixed correct section of the manifest. Then after that, there's a bit of giving our AI agents or the Gemini CLI more capabilities. So the use of the GKE MCP. So MCP, I said, is the model context protocol. It's a way of giving our AI that advanced level capabilities of having access to external information. So in this case, the GKE MCP server gives Antigravity CLI access to our Kubernetes clusters. So what do we need to do? So for this, we just need to create a directory within the .gemini file path. So I do exactly that. So more human in the loop, I need to give it permission. Then after that, I need to add the GKE MCP server extension. So here is the code for you to integrate the GKE MCP server configuring. Then after that, I need to give it permission. Then after that, I just simply need to debug the failed part of the front-end application. Still give it more permission. So most of us as DevOps engineers, we like going the YOLO mode. At times, you might prefer doing it you only look once, but I always recommend following the approach of the agents coming back to you to ask for permission before it does any changes. Still thinking, try to fix our issues within our Kubernetes environment. We still need to give them permission to list the different Kubernetes files. And yeah, so that's basically how we can involve AI in our Kubernetes environment. So the last step, it's basically about having the different agent skills. So agent skills are defined within your Gemini folder. So you just need to define .gemini. If at all you are using Antigravity CLI, you need to have a .antigravity. Then you can have skills.md. So in this case, I already had the Kubernetes troubleshooter. So I want to show you that. So here it is, the skills.md. So this one now allows us to give our AI that consistent, let me drag these. Nice. So the skills.md allows us to be able to bring in the reusability of how do you want our AI to work within our environment. So in this case, I wanted our the Gemini CLI to be able to troubleshoot our manifest file. So we just need to define exactly that. So this is well defined, and it's going to use these skills as it's going to debug our application environment. So that's basically it. So I hope that you're going to have some time after the session to go through this Codelab. And the most important part is to make sure that you tear down your environment, because it's going to probably take you around 5 credits or charge you within your credit cards. So with that, probably I can respond to questions if there are any. Steven or Diana, I see I'm out of time.
Yes, Samuel, really, 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 really insightful. And to the note around time management, kudos, kudos, kudos. Very,
Nice,
very, very
nice.
insightful session. You know, I think you came from sharing Google kills products, and I think we keep tabs on killed by Google. I'm a big Google fan, but the rate at which they kill products is really worrying sometimes. That you want to learn something, but then you're like, what if it's killed because it's not adopted by a huge number of engineers? but I think anti-gravity is really here. And I think as you shared, we moved from a way of, I copy error messages from, say, if I'm working with the Kubernetes cluster, to paste them in the Gemini UI, and I wait for response. But yeah, Gemini has context already of my cluster, and you can seamlessly troubleshoot. And further down the line, you can work with MCP and work with skills. And then also being able to utilize that Gemini.md is really, really, really insightful. I think it's something we are seeing across all repos where you have Cloud.md, Gemini.md. So yes, AI has context of your repo. Yeah. But thanks so much. In the interest of time, I will encourage attendees to connect with you on your socials. I think you had shared them earlier, so that they can be able to engage you, follow you, and also keep tabs on what's going on.